Hi guys. I come from a sales background, not a professor background. So normally I get 30 seconds, then I'm kicked out the door. So 15 minutes is a bit of a stretch for me in the other way. We started off actually from an investment background, and we've been investing into environmental projects for about 6-7 years now, ranging from clean technology all the way through to carbon credits and forest protection. We made the front page of Time magazine with our project in Indonesia, banking on trees, and we've also been finalists in a number of different awards, and we won the carbon financing deal of the year. But what was really interesting was in 2008, I saw this and had to take a photo. It was just amazing. Just the sheer amount of biomass outside of this palm mill, which we were actually doing some CDM work for, some carbon work for. And what we found, which was so fascinating, was from an investor perspective, this waste looks like some type of externality, some type of problem. And here we are talking about waste stream 1, which is EFB. Now, everyone here knows what EFB is. Obviously, as well, it's a huge opportunity. A standard 45-tonner mill will generate over 200 tons per day. And so the amount of generated, estimated EFB is in excess of 40 million tons per year. Unfortunately, my camera could not capture the smell of this photo, but I've visited many ponds, and every time it's a hair-raising experience. Again, what's even more interesting about this waste stream is the impact that it has on waterways, water streams, and communities. And so again, we found that waste stream 2 was both an opportunity and a threat. We then started also working deeply on the demand side, the consumer side, and obviously the work which is being done with RSPO, and particularly Principle 5, where 5.3 and 5.6 directly implicated with the waste streams. We found it really interesting to see whole countries, to see this movement over the last 5 years in terms of sustainability requirements. You don't have to read this. These are some of the local regulations as well in Malaysia and Indonesia, and these are some of the regulations in Colombia. Actually, Daryl and I were both in Colombia just a few weeks ago, and he must have liked my presentation so much that he asked me to do it again. Get it again. And if any of you haven't been to Colombia, I strongly recommend it. It's an amazing country. So some of the old ways of dealing with waste included burning, included the mulching, included irrigation. But from an investor perspective, we knew that there must be alternative ways. And we also looked at the ways that the pain points of the palm industry could be potentially addressed. We looked at, obviously, waste disposal causes pollution, community issues, as well as public pressure. There's also a much greater demand because of the perceived food security issues. There's a much bigger demand for fertilizer, and there's also obviously the peak potash and the future price points expected to go up, obviously. And the last one, which I find very interesting, particularly for Malaysia, where you've had several generations of palm, is the issue of sustainable soil and the requirement for greater amounts of fertilizer in order to get the same yields or even declining yields. So our approach really was coming at it from an investor perspective. We looked at a range of different solutions to try to find the most cost-effective use of the waste. We also looked at, obviously, the economics. So sometimes depending on where the location of the mill is, what the surrounding opportunity cost of that waste is, the reliability of the result, the speed, the long-term suitability of the solution, and also obviously the volumes and the nature of the EFB and the POMI. And finally, we looked at how could the solution support some form of sustainable and integrated, intensified agriculture, because we're very big believers of the cradle-to-cradle solution. So, as most of you know, these are some of the current generation solutions. You've got first generation lagoon ponds where you've got the covers. Now, just at the close of business last Friday, the spot price for CERs, carbon credits, was below €1. And so on top of that, a lot of these pond covers have not been even realizing the estimated amount of credits Furthermore, it still has the EFB and some of the residual liquids. So we felt that this solution was a partial solution. It wasn't fully complete. In terms of the biogas digester, obviously it is a more effective solution with a higher capex. But again, we felt that if you're looking for some of your payback to come from carbon, there was going to be obviously some issues there, as well as the amount of EFB that was still not being utilized by this solution, as well as obviously different digesters have different sizes, and depending on whether or not the mill was already power sufficient or whether it had to look at a feed-in tariff and negotiate with PLN, which is its own journey of exploration and patience. And then we also looked at the co-composting, where you've got outdoor windrows. Some of the challenges here obviously are the high rainfall in many of the locations, the long process in terms of getting it to a compostable state, so sometimes looking at 6 to 10 weeks even, and particularly obviously looking at the amount of land area required for such solutions. So what we found, which was really fascinating, and actually one of the grandfathers of composting, Simon Lord, is sitting in the front row, so I'm a little nervous. And we've also got one of our clients on Land Sumatra, as well as Sokfin. These are the pilots that they've built. The aerated bunkers have the roofing, as you can see, with sprinklers which allow for the pommy to be sprayed into the EFB and the mixture. Along the flooring, they've got the aerated spigots. So there's a number of special custom spigots inside of the grooves which continually blow oxygen into the mix, allowing for greater drying effect. And then you've also got the service corridor with the fans and the control panels. The principle here as well is similar to trying to get as much oxygen to optimize the aerobic breakdown. So we don't use any microbes, there aren't any enzymes used. However, there are some experiments ongoing, but the interesting opportunity is by blowing the air continually and the turning process. So from bunker to bunker every 3 days, we have a process where a front loader will take out the mix, dump it into the back of this custom-made machine, which has the, if you look at the pipe on the left-hand corner, which is pumping the pommy and then spraying it into the mix. You can see the steam rising off because it's trying to hit an optimal 70 to 80 degrees. Again, you can see here the machine allows for the compost mix to be thrown up to 6 meters high, and that allows for less land usage, which also obviously allows for higher stacking. You can also mix in boiler ash and some of the other additives which allow for more nutrients. And here's just an example of the finished product. We've got technology thermometers which measure methane, oxygen, and obviously the temperature. And what we find is that if the compost ever hits a temperature of about 80 degrees, we can spray more pommy on. If it drops lower, approaching the 60-degree mark, we let the aerobic breakdown build the temperature back up. What's interesting is a lot of people will compare this to the open windrows, and the reason why we believe that a little bit more capex is beneficial as opposed to the open windrows is particularly in high rainfall areas, as well as if you look at the blue component in the windrow area. Number one, obviously windrows are much shorter. They don't have the same stack, so it takes up a bigger area. But two, it takes a much longer period of time without the oxygen, without the aeration, to get the actual aerobic breakdown optimal conditions, which is why the blue area indicates a lower temperature. So the optimal aerobic breakdown only really occurs in the outer area of the rhombus shape, whereas within the aerated bunkers you can get a much deeper oxygenation. Here's just an example of some of the stacks. So coming back to the nutrition component, what we identify as a long-term risk to the entire industry is one, sustainable soil, and two, the cost of nutrients and the cost of fertilizer. Here we're looking at how the NPK can be held in the soil, the palm, the FFB, the EFB, the pommy, and then into the compost. Now, what's interesting is obviously there's not a lot of nutrients in the oil or the actual product which is sold. So how is it that we would interpret that the waste should be thrown away and not utilized? Seems to be illogical to us. So it's how do we create the holistic cradle-to-cradle solution? My actual background originally was in technology, so we've brought a lot of interest in constant monitoring, and you can see that we're constantly looking at 24-hour surveillance for the compost. One of the benefits for aeration from our perspective is it's fast. So we have not yet seen a solution which has brought a faster turnaround. So one cycle will be 3 to 4 days in each bunker, lasting normally about 25, at most 30 days to bring it to about a 65 to 67% moisture. Secondly, it's less concrete. We've seen some areas which have had literally an acre of concrete laid down in an open format, which we thought was not the most optimal use of cost. And also less labor because of the automation that we're building into the process. And finally, it's the most efficient in terms of recycling nutrients, which we think is key to the future. So currently, I feel the industry is at a bit of a tipping point. And again, as industry members, one of the questions which has been posed is, why is there no mass adoption or tipping point of composting or aeration? And from our perspective, we thought some of the key risks were previously there was no technology that could reliably produce the nutrients. Secondly, the compost and the nutrients in them. Secondly, now there is a much greater need for sustainable soil management, looking at the next 30 years moving forward. And there's also greater scientific proof for the nutrient improvements compared to mulching. And finally, as well, there's the greater focus on emissions and greenhouse gas and sustainability. The agronomic advantages of compost, obviously, is what I'll now talk a little bit about. So obviously, maximum nutrient recycling. It's more effective in terms of the slow release of nutrients. Less nutrient waste, so often when you're throwing powder down, if it rains, if it's not at the right moisture, if there's wind, if it's not thrown in the right location, nutrients from the slow release compost, you can see it, it's very visible, right product, right rate, right time, right place. It's also an effective way to cover the whole plantation because it's a lot lighter and drier than the mulching. So wet EFB often is only applied in a very small area around the mill. Finally, we look at the yields from long-term use. We're slightly different as investors because we look at how do you get the maximum yield from a piece of land over a 30 to 50 year time frame rather than quarterly results, which most financial institutions look at. In terms of the last kind of component of the benefits of the soil, the chemical properties from the compost is obviously improved in terms of micronutrients and the buffering capacity, the ability to stabilize some of the nutrients and the active agents for growth and germination. Physical properties are improved in terms of the soil bulk density and the absorption for water, the root penetration and the stability, and obviously the aeration. And then in terms of the biological properties, again, there are obviously a lot of benefits from the compost that we've found. An interesting study was done by scientists associated with the Lonesome Group, where they found that by applying 10 to 15 tons of organic compost per hectare, they were able to potentially get 27% yield increases over a period of time when replacing average N and P fertilizers. So this is just a comparison between the urea in terms of application and then yields versus organic compost. It's publicly available if you're interested. Also, we've had a bunch of success in terms of our projects. So we have one project in particular which has underpinned the program of works. So we've got a POA now approved in Indonesia. So if people are looking to do composting in Indonesia, we can easily add on new projects. And this was successful in June, so we're very pleased about that. obviously the price of carbon is not something that we're pleased about. And we also have a project going through in Colombia, the La Gloria project, which is now in its initializing processes. So it's built and the carbon is through. So thank you very much, and as promised, I'm done within 15 minutes and look forward to questions. Thank you.